Good day, everyone. I'm Teacher Kim, and welcome to another week of Maritime English, week 41, day 1. And we'll be talking about one of the most important safety practices on board, the Maritime English Failure Drill. Be ready, be safe, because in the engine room, being ready can make the difference between a safe operation and a serious accident. But before we start, here's our lesson agenda for today. First, we have the introduction where we'll learn what the topic is all about. Second, we'll move to understanding English failure to know the common causes and effects. Third, we'll talk about preparedness for safety and how being ready can prevent accidents. Fourth, we'll discuss the critical purpose of drills, why we practice, and how it helps the crew. Fifth, we'll cover regulatory requirements and compliance, the rules that guide our safety drills. Next, we'll go through the engine failure drill procedure step by step on how the drill is done. And finally, we'll end with a summary and conclusion to review the key points of our lesson. So let's begin and learn how to stay ready and safe during an engine failure. Introduction to English to engine drills. So let's go over our lesson objectives. First, we'll understand what an engine failure drill is. Second, we'll learn why drills are important for safety. Third, we'll practice using simple English communication during drills. This is essential when working with an international crew. And lastly, we'll know the basic regulations that require these drills like SALAS and the ISM code. So, what exactly is a drill? A drill is a practice exercise that prepares us for real life emergencies. We don't wait for an accident to happen before learning what to do. We train in advance. As we say, we practice today so we can save lives tomorrow. That's what drills are all about. Safety through preparation. Again, we practice today so we can save lives tomorrow. safety through preparation. What is an engine failure drill? An engine failure drill is a simulation where the crew acts out what to do when the ship's main engine stops unexpectedly. The simple goal is make sure everyone knows their duties, follows proper procedures, and communicates clearly. In real situations, every second counts. So practicing helps us stay calm and focused when things go wrong. Again, our goal is to make sure everyone knows their duty and can communicate clearly. So, why we practice drills? So, why do we keep practicing these drills? It's because drills help us stay calm during emergencies. They allow us to check the crew's readiness, to see if everyone remembers their roles, and most importantly, they help us build teamwork and coordination. When everyone knows what to do, we avoid confusion and mistakes. So remember to stay calm during emergencies, to check the crew's readiness, and to train teamwork and coordination. With this, we avoid confusion and mistakes. Importance of preparedness. So, preparedness means being ready, and readiness brings safety and confidence. So, when you are prepared, you or we can be fast react. So, fast react when something goes wrong. Next, communicate clearly. Communicate clearly with our team and prevent accidents. Prevent small issues from turning into big accidents. Again, remember safety plus confidence is equals to preparedness. React fast, communicate clearly, and prevent accidents. Remember, confidence in drills leads to confidence in real emergencies. Again, confidence in drills leads to confidence in real emergencies. So, here are some basic drill vocabulary that we'll use often. Drill, practice, exercise. Drill means a practice exercise. Emergency, dangerous situation. Emergency is a dangerous situation that needs quick action. Alarm, warning sound. Alarm is a warning sound that signals danger. Procedure means a step set of step-by-step actions to follow. Procedure is a step-by-step action. Report, give information. Report means giving information about what happened. So let's recap our basic drill words. Drill, to practice exercise. Emergency, dangerous situation. Alarm, warning sound. Procedure, step by step action. Lastly, report, give information. These are simple but powerful words. Use them clearly during communications. Basic drill commands. In every drill, commands are short and clear. Here are some examples you'll hear or use. Start the drill. Stop the drill. Report to chief. Reset alarm. Secure the engine. Again, let's repeat some of our basic drill commands. Start the drill. Stop the drill. Report to chief. Reset alarm. And secure the engine. That's time. That's the kind of clear, confident voice we use during drills. Teamwork in drills. Each crew member has a specific role to perform. The chief engineer supervises all engine operations and gives instructions to the team. The duty engineers monitors the machinery and reports any problems right away. And the oiler or wiper assists and supports the engineers during the drills. When everyone does their part and communicates clearly, the drill runs smoothly. That's why we say good teamwork equals successful drill. Working together helps ensure safety, quick action, and proper coordination in real emergencies. When the main engine stops. So when the ship's main engine stops, it's a serious situation. The ship loses propulsion, meaning it can no longer move forward. If this happens while at sea, especially in rough weather, the vessel may start to drift or lose control. This increases the danger of hitting another ship or running aground. That's why drills and readiness are so important. By practicing what to do during an emergency or engine failure, the crew can respond quickly, avoid panic, and keep the vessel safe. And remember, being prepared is the best way to prevent accidents. Remember, being prepared is the best way to prevent accident. Now, let's go on to our next lesson. Understanding engine failure. Because engine failure happens when the main engine stops or loses power. So, when this occurs, the ship can't move or steer properly, which is dangerous at sea. That's why it's important for the crew to know what causes engine failure or how to respond quickly. Here are some of the common causes of engine failure. There are many possible causes of engine failure. It can be fuel system problem, like no fuel reaching the engine. A cooling system problem where the engine overheats. A lubrication system issue, which means not enough oil to protect the moving parts. Sometimes it's an electrical fault where the control system or power supply fails. And lastly, human error. Mistakes made by the crew, like wrong operation or missed maintenance. Again, these are the common causes of engine failure: fuel system problem, cooling system problem, lubrication system issue, electrical fault, and human error. All of these can cause the engine to stop unexpectedly. So let's go to some samples of this common engine failure. First is the fuel system failure. So when there's no fuel supply, the engine cannot start or continue running. So the crew should check the fuel valves, filters, and fuel pumps to find the blockage or cause of the problem. Again, no fuel supply is equals to engine cannot start. So keeping the fuel system clean and maintained is the key to preventing this kind of failure. Next, cooling system problem. So cooling system problems are almost common. When the engine temperature gets too high, it may overheat. To fix this, the crew should reduce the engine load, then check the seawater pump and filters to make sure cooling water is flowing properly. Again, high temperature is equals to possible overheating. So overheating can lead to total engine shutdown if it is not handled quickly. Again, overheating can lead to total engine shutdown if not handled quickly. Next, we have lubrication system issue. When the oil pressure is too low, it can cause serious engine damage because the moving parts aren't protected. The correct action is to stop the engine, check the oil level, and restart only when it's safe. Again, lubrication system issue has low oil pressure that can cause engine damage risk. So this protects the machinery and avoids bigger repairs later. So always remember to check the engine, check the oil level, and restart only when it's safe. Next sample is electrical fault. When there's no power going to the control system, the engine will stop. So no power to control panel can lead to engine control lost. So to solve this, the action taken should be crew should check the breakers, fuses, and generator output. Because even small electrical faults can cause a big problem. So quick checking and action are very important. And lastly, human error. Sometimes engine failure happens because of human error, like wrong operation or missed inspection. Again, mistakes in operation leads to engine or system affected. That's why it is important to always follow standard procedures and double check our work to avoid mistakes. Again, follow correct procedures, report immediately, review mistakes during the drills. So always double check your work to avoid mistakes. Now let's proceed to engine room alarms and indicators. In the engine room, these indicator lights help the crew monitor the system's coordination. We have the green light, normal condition or operation system running. So it means a normal operation and everything is running properly. Next is the red light or danger. The red light signals are a general alarm or emergency stop, which means immediate action is required. So last is the orange or amber colored warning fault, meaning something needs attention. Again, green light is for normal condition or the operation system is running properly. Red light means danger, general alarm, or emergency stop, which means you need an immediate action for this. And orange or amber light shows a warning or fault, meaning something needs an attention. So by remembering these lights, the crew can respond quickly and keep the engine safe from damage. Again, by these lights or understanding these lights, the crew can respond quickly and keep the engine safe from danger. Now, let's go to our first indicator, the sprinkler or water mist system status. So as you can see, this icon is a water spray symbol representing fine mist or a sprinkle nozzle, meaning this indicates the condition of the fire. The fire suspension system. If the light is on, It could mean that the system is active, or there's a fault or pressure drop. The purpose of this is to ensure the engine room's automatic firefighting system is ready to operate, or alerts the crew if there's an issue with the sprinkler or water mist lines. Next, fire alarm. As you can see in our picture, the icon is a flame symbol inside a red square, meaning this alarm flashes or sounds when fire or smoke is detected. So the purpose is to warn the crew to act immediately, locate the fire, and follow firefighting procedures. The red color universally signals danger and urgency. So that is the fire alarm. Next is the CO2 release warning. So as you can see, the icon letters CO2 with gas release symbol showing emission, meaning this indicator lights up before the release of carbon dioxide into the engine room to suppress fire. So the purpose is a critical evacuation warning. Once CO2 is discharged, oxygen levels drop, making it unsafe for personnel, and all crew must leave the area immediately. Again, the purpose of this, once the CO2 is discharged, oxygen levels drop, making it unsafe for personnel. So all crew must leave the area immediately. Next is the machinery fault or engine problem. As you can see in our picture, this icon like gear or cog symbol representing machinery operation. This color yellow icon meaning it alerts engineers that there is an abnormality or malfunction. For example, low oil pressure, high temperature, or system failure. So the purpose of this is to prompt the crew to check equipment quickly and prevent damage or engine shutdown. Again, the purpose of this is to prompt the crew to check equipment quickly and prevent damage or engine shutdown. Next is the general status or engine control room, ECR. So you can see the icon is a semicircle with a vertical pointer and a lever-like handle above, symbolizing operational status or power. Meaning, it shows the general condition or power mode of the engine control system. It may also indicate which station currently has control, bridge, ACR, or local. The purpose is to help maintain proper coordination between control locations to avoid conflicting commands. Again, the purpose of this indicator is to help maintain proper coordination between control locations to avoid conflicting commands. Lastly, the communication or telephone alarm. As you can see, it is a telephone handset symbol, meaning indicates an incoming call or message from another station, usually from the bridge or accommodation area. The purpose is to ensure clear and immediate communication. So again, the purpose this alarm is to ensure clear and immediate communication. So now that we know of the alarms and indicators on the engine room, let's proceed to the effects of engine failure. So when the ship's engine fails, it creates many serious problems that can affect the entire voyage. So first, the most important effect is the loss of propulsion. This means the ship cannot move forward or backward because the engine, which provides power to the propeller, has stopped working. Without propulsion, the ship will just float or drift in the water. And when this happens, the voyage will be delayed because of the ship can't reach its destination on time. So delays may also affect the ship's schedule, cargo delivery, and even cause financial losses. And another effect is the navigation risk. If the ship cannot be controlled, it may drift off its planned course, especially if there are strong winds or ocean currents. This can put the vessel in danger. And the worst situations, an engine failure can lead to possible collisions with other vessels or even grounding, which means the ship could hit shallow areas or rocks. Both incidents can cause serious damage to the ship and harm the crew or environment. So remember, effects of engine failure when unmaintained is loss of propulsion, delayed in voyage, navigational risk, possible collision, or grounding. That's why during an engine failure, it's very important for the crew to act quickly, communicate properly, and follow emergency procedures to restore the engine and ensure everyone's safety. Again, it's very important for the crew to act quickly, communicate properly, and follow emergency procedures to avoid these effects when engine failure happens. So, what are the responsibility of engine crews? So, observe machinery condition. This means that engine crew must always watch and check the machines, like engines, pumps, to make sure they are working properly. They need to listen for strange sounds, watch for leaks, and monitor temperature or pressure levels. Report any abnormalities immediately. So if the crew notices something unusual like oil leak, vibration, or alarm, they must inform the chief engineer quickly or right away because reporting helps prevent small problems from becoming big failures. Follow the chief engineer's orders. So during drills or real emergencies, the chief engineer gives instructions on what to do. The crew must listen carefully and follow the orders exactly and avoid acting on their own. This ensures safety, teamwork, and proper handling of the situation. So again, the responsibility of engine crew are to observe machinery condition, report abnormalities, and follow orders from chief engineer. Next is the procedure after engine failure. So after an engine failure, the crew must act fast and follow a set procedure. Firstly, is to identify the alarm and find out what went wrong. Next, report situation. Report situation to the chief engineer. Then, check systems. Check the affected system, take corrective action. And lastly, record everything in the logbook for documentation. So this ensures all actions are properly tracked. So remember, identify alarm, report situation, check systems, take active corrective action, and record in logbook. This ensures all actions are properly tracked. So let's have an example for this kind of situation. And let's incorporate the procedure after engine failure. So the problem is the main engine stopped due to low oil pressure. So the crew must act fast and follow a set procedure. First is identify alarm. So the problem is the alarm shows low oil pressure, indicating a problem in the oil system. So next is report situation. So the crew immediately informs the chief engineer about the engine stoppage. And also, we should report it to the bridge for well coordination. And next, check system. The crew inspects the oil system to find leaks or low oil levels. So the chief engineer and the team inspects the lube oil system. Next is take corrective action. So they refill or repair the oil system and ensure it's functioning properly. After that, it is ready to restart the main engine. And lastly, record in log all actions and observation are written in the logbook for documentation. So incident logged, corrective action completed successfully. So you have to follow this procedure for proper documentation and for reference also for the future. So, importance of clear reporting. During emergencies, clear communication saves time and prevents mistakes. Simple and correct reporting avoids confusion. That's why we use short and simple English when reporting, like engine stopped, checking system now. Because clear reporting ensures that everyone understands the situation and takes the right action. Again, simple and correct reporting avoids confusion. So let's go to our next lesson, the preparedness for safety. So why we drill? To train crew to respond correctly and calmly during emergencies. So we conduct these drills to train the crew to respond correctly and calmly during emergency, because these exercises help everyone know what to do. So when a real situation happens, there's no panic, just action. Drills build confidence. Again, repeated practice gives confidence and better action in real situations. So practicing drills regularly builds confidence. And the more we train, the more natural our response becomes. So in real accidents or real situation, confidence helps us think clearly and work effectively as a team. So safety preparedness concept. Safety preparedness means being both mentally and physically ready at all times. It's not just knowing the procedures. It's all about being alert, focused, and ready to act immediately when something goes wrong. So, ready mind plus ready body is equals to safety preparedness, because being alert, focused, and ready is equal to safety preparedness. Now let's go on to preventing panic. A trained and prepared crew does not panic. They follow procedures, communicate properly, and stay calm. Because panic can make a small problem worse, but preparedness keeps everything under control. Next, engine room safety precautions. So, safety always comes first. Before doing anything in the engine room, safety should always be the top priority. Every task, even a small one, should be done with care to prevent accidents or injuries. So safety always comes first. Next, the engine room is hot, loud, and dangerous. So the engine room has running machineries, high temperatures, and strong noises. It can be risky if you're not alert. So crew must wear proper protective gear like ear protection, gloves, and safety shoes. Next is always follow safety rules during work and drills. So safety rules are made to protect everyone during work or drills. Following procedures step by step ensures that no one gets hurt and that the equipment stays in good condition. Lastly, never take shortcuts with machines. Taking shortcuts like skipping safety checks or rushing a repair can cause accidents or equipment failure. It's better to take time and do the job correctly than to risk injury or damage. So, personal protective equipment or PPE. Always wear PPE. First is safety helmet or hard hat. This protects the head from falling objects, bumps, or accidental hits while working around machinery or low ceilings. Next is safety shoes. Prevents foot injuries from heavy tools, sleeping or slippery surfaces, or stepping on sharp objects. They usually have steel toes and non-slip soles. Ear protection. The engine room is very noisy, which can damage hearing over time. So earplugs or earmuffs reduce noise and protect the ears. Gloves Pro- protects hand from burns, cuts, and contact with hot or oily parts. So different gloves are used depending on the job. For example, heat resistant and rubber, and so on. Lastly is coveralls, a full body uniform that keeps the body safe from dirt, oil, and heat. It also prevents loose clothing from getting caught in moving machinery. So remember to always use proper and complete personal protective equipments when in engine room to protect you from any engine failure problems. Fire and hot surface hazards. In the engine room, many parts like pipes and machinery becomes extremely hot during operation. That's why we must always keep oil and fuel away from these surfaces because they can easily catch fire. Never touch hot pipes without proper protection because they can cause serious burns. If you see any leakage, or report them immediately to prevent fire and accidents. And remember, quick reporting and awareness can save lives and equipment. Again, remember, quick reporting and awareness can save lives and equipment. Next, electrical and mechanical hazard. So, in the engine room, there are many moving machines and electrical system that can be dangerous if not handled properly. Always stay alert around moving machinery like motors, pumps, belts. Keep hands and clothing away. Before doing any maintenance, make sure electrical isolation is done. This means cutting off power to the equipment. Use lockout or tag out procedures to ensure no accidentally turns on the machine while you're working. And always use proper tools for the job to prevent injury and damage. Next is the good housekeeping. In the engine room, good housekeeping keeps everyone safe. Always keep the area clean and dry to avoid slips and accidents. If there's an oil spill, clean it immediately. Even small spills can cause danger. After using tools, remember to always return them to their proper place so others can find them easily. Remember, a clean engine room means safe working conditions for all. Again, remember, a clean engine room means safe working conditions for all. Because safety starts with awareness and the right equipment. Emergency escape and communication. In case of an emergency, always know your escape routes so you can exit safely and quickly. Make sure passages are clear. Never block them with tools or equipment. That's why it is a routine to return the tools that you use properly on their designated place. During emergencies, use clear and simple English when communicating, like fire in engine room or evacuate now. Good communication and clear escape paths can save lives during critical moments. Next, command words to remember. So these command words are essential during drills and emergencies. Report. Give information about what's happening. Acknowledge. Firm order that you received. Proceed. Continue the task safely. And secure. Make sure the system or equipment is safe. So remember these command words. Report is to give information. Acknowledge is to confirm order. Proceed is to continue task. And secure means make safe. Because using these words keeps communication clear and organized. So let's talk about communication flow. Because good communication follows a simple flow. As you can see in our picture, order, action, confirmation, and report. So the chief gives the order, the crew takes action, gives completion, and reports back. This cycle or this communication flow prevents misunderstanding and ensures proper coordination. Again, the communication flow is order, action, confirmation, and report. So, what is effective communication? Use short, simple English words during emergencies. So, for example, engine stopped, check oil, restart complete. Because clear words saves time and avoid confusion, especially in stressful situations. Again, use short, simple English words during emergencies. Next is the safety culture on board. Safety is not just for drills. It's a daily habit. Everyone on board shares the responsibilities to keep the workplace safe and always have the right attitude. Take no shortcuts and practice everyday awareness in everything you do. Again, safety is not just drills. It's a daily habit. So, team responsibility, everyday awareness, learning attitude, and no shortcuts to keep the workplace safe. So, what are the benefits of preparedness? When we prepared, we gain many advantages that makes a real difference during emergencies. First is faster response. So everyone knows what to do, saving valuable time. Next is less confusion. Clear communication and defined roles prevent mistakes. Next is better teamwork. Crew members support one another effectively. And because of that, fewer accidents. Proper training and awareness reduces risk. When safety becomes part of your routine, accidents are prevented and teamwork becomes stronger. Again, remember that safety becomes part of our routine. Accidents are prevented and teamwork becomes stronger. So here are some safety reminders that you should always remember. Safety first. Again, don't take shortcuts. Practice is equals to protection. The more you train, the safer you are. Prepared crew is equals to safe ship. Teamwork and readiness keep everyone safe. So preparedness is the first step to safety and survival. Preparedness, it's not just a drill, it's about building confidence, coordination, and discipline. When the crew is ready, the ship, its people, and its mission are all protected. So let's proceed to the next topic. The critical purpose of drills. Drills are one of the most important parts of the safety training on board. They prepare us for real emergencies so that when something happens, we don't panic. We act with confidence and coordination. So, purpose of drills. So, the main goal of every drill is to test how well the crew can respond during real emergencies. It's not just about following orders, but knowing exactly what to do under pressure. So that is the purpose of drills. To stay focused, so learning through practice. So drills are learning tools, not opportunities for blame. Mistakes made during drills are valuable lessons. They highlight what needs improvement by practicing repeatedly. The the crew gains confidence and competence. So each drill allows us to correct errors, improve coordination, and feel more assured that in real situations, we'll respond effectively. So, finding weakness. Drills reveal both our strengths and weaknesses. So, identifying weak points during practice is far safer than discovering them during an actual emergency. For instance, a miscommunication or delayed action in a drill can be analyzed and corrected immediately. This proactive approach ensures the crew is better prepared for the unexpected. So, weakness is identifying the weak points during the practice, not the actual emergency. So, preparedness is very important. So, next is improving reaction time. Practice builds confidence and speed. A well-trained crew reacts fast and correctly. So, regular drills helps the crew react fast. Repetition trains the mind and body to act instinctively, reducing hesitation. Quick and confident actions are critical in emergencies, where every second counts. By practicing, we develop speed and accuracy that protect both lives and machinery. Remember, regular drills help the crew react faster. Next is from chaos to control. As you can see in our picture, the before and after, the chaos or before and after drill. Before drills, the engine room can be chaotic. Alarms blaring, crew unsure, and task overlapping. After regular drills, everyone knows their role, communicates clearly, and acts efficiently. Drills turn confusion into calm. So building confidence and ensuring safety under pressure. Communication under stress. Clear communication is the key in emergencies. Drills emphasize using simple, direct English to avoid confusion. Orders must be understandable by all crew members, even in stressful situations, because practicing communication during drills ensure that no instruction is misinterpreted and that everyone knows exactly what to do. So always use short, simple words. Team coordination. Safety on board is a team effort. Drills teach us that each crew member has a defined role, and success depends on following orders in the correct sequence. Coordination ensures that all actions completed and complemented one another, preventing mistakes and making operations smoother and safer. Teamwork in drills reflects teamwork in real emergencies. Every crew member has a duty. Follow orders in correct sequence. Remember, teamwork in drills reflect teamwork in real emergencies. So, what are the emergency response sequence? So, safety on board is a team effort. Drills teach us that each crew member has a defined role. So, first is detect the problem. Next is report immediately. Third, take action. Fourth, restore system. And lastly, record results. So what is the difference between emergency response sequence and the procedure after engine failure? But before that, let's make an example for proper response. For example, a crew member sees fuel oil spraying from a pipe connection in the engine room. First, notice leak, fuel leak, smell, or alarm. Second, inform duty or chief engineer. Third, stop fuel supply, cut power, prepare extinguisher, and ventilate area. Fourth, repair leak, clean oil, and restart only after safety check. And lastly, log incident and report to chief engineer and safety officer. So what's the difference between procedure after engine failure versus the emergency response sequence? So do so procedure after engine failure focuses on how to fix the problem. It guides the crew step by step on actions to repair or address the engine issue. Think of it as how to manual during the emergency. And emergency response sequence focuses on what to do first to manage the situation. It prioritizes detection, reporting, immediate action, system restoration, and documentation. Think of it as the what to do first roadmap to handle emergencies safely and effectively. So don't be confused between the two. Next is the drill evaluation. After each drill, officers record key information. First is take or time taken to complete task, action performed, and the crew's overall response. Because evaluations identify areas of improvement and track progress over time. This feedback is critical for refining procedures, enhancing readiness, and ensuring that the crew is prepared for real emergencies. So, what are the benefits of regular drills? So, regular drills build more than just technical skills. They foster awareness, discipline, and teamwork among the crew. They also cultivate a culture of safety where everyone knows their responsibilities and acts decisively. The ultimate benefit is creating a safer environment where risks are minimized and confidence is high. So the benefits of regular drills is improve safety awareness, strong discipline, faster and safer response. So, what is the role of a chief engineer? The chief engineer is the leader of the drill. They give instructions, oversee the process, and evaluate the performance of each crew member. Their role is essential to ensure that the procedures are followed correctly and that the crew meets the highest safety standards. A strong leader sets the tone for discipline and efficiency. So, chief engineer supervises the control drill, gives clear orders, and evaluates crew actions. Next, what is the role of a duty engineer? Monitor machinery during drills. making sure system responds correctly, operates valves, pumps, and system. They identify abnormalities, report issues promptly, and follow instructions to stabilize the situation. So their careful monitoring ensures that the drills simulate real emergency safety and effectively. And what are the role of the support crew? Assist in checking pumps, valves, and readings. Support engineers in following procedures. The support crew assists by checking pumps, valves, and readings, respond, responding quickly to issues, and reporting accurately. Their action help restore system efficiently and demonstrate the importance of teamwork because every member's contribution matters in achieving smooth and effective emergency responses. Now let's move on to our next lesson, the regulatory and compliance. Safety drills are not just best practices. They are legal requirements. Regulations ensure that ships operate safely and that the crew is prepared for emergencies. Compliance protects both the people on board and the environment. Why regulations are important? International regulations make sure all ships maintain the same safety standards. So, rules and regulations exist to keep ship, crew, and cargo safe. They standardize procedure, minimize risk, and make sure that everyone follows best practices during emergencies. Without these rules, accidents and confusion could be much more frequent and severe. So, who requires drills? So, these are the main authorities. As you can see in our picture, the IMO or the International Maritime Organization, the IMO SOLAS, Safety of Life at Sea, and the ISM Code, the International Safety Management Code. So, main authorities' purpose is to set global rules to ensure safe, secure, and pollution-free shipping. The IMO makes international rules or safety standards, security, and environmental performance for ships. This ensures that all ships follow consistent rules to protect crew, passengers, and the ocean. So SOLAS focuses on safety of people and ships. So it conducts regular safety drills. This includes engine failures, fire emergencies, and evacuation procedure. Regular drills ensure the crew are always ready to respond effectively. Engine drill regulations. Ship must conduct engine drills to ensure machinery and crew are ready. SOLAS effectively or specifically requires all ships conduct regular safety drills. This includes engine failures, fire emergencies, and evacuate procedures. So regular drills are ensured. Frequency of drills. Engine drills are conducted at least once every 3 months or as required by the company policies. Most ship conduct drills once every 3 months. So regular drills maintain crew competence and or ensures that emergency procedure remains fresh in everyone. Next is documentation of drills. All drills must be recorded in ship's logbook so that records provide proof of compliance, allow for performance tracking, and help identify areas for improvement. And proper documentation is critical part of safety management. So here is the sample logbook entry. During drills and inspections, certain words are important, like record, write down details, verify, check accuracy, audit, inspection by authorities, and follow up. So as you can see, here are the competent terms like record, write down results, verify, confirm action, audit or inspection, report, or document findings. So here are sample compliance words during drills and inspection. So some certain words are important as record, verify, audit, and follow-ups. Record is to write down the details. Verify is to check accuracy. Audit is inspection by authorities. And follow-up, next action to the correct or improve. Using these words correctly ensures clear communication and proper documentation. So what are the responsibilities during engine drills? So first, the master ensures drills are conducted and records are completed. This oversight guarantees that the ship meets international regulations and the crew remains prepared for emergency. Chief engineer plans, supervises, and reviews engine drills. This role is critical for evaluating how the engine room and crew respond to a simulated emergency, ensuring procedures are followed correctly and efficiently. Safety officer checks compliance, evaluates results, and reports to the master. So they provide an independent assessment of readiness, helping to identify areas for improvement and ensure continuous safety on board. So here is the drill reporting process. As you can see, we have conduct drill, which practice the emergency scenario with the crew. Record, document actions taken, time, and observations in the logbook. Review, chief engineer and safety officers evaluate performance and identify improvements. And submit report. Forward the findings to the master for compliance and follow up. So remember, conduct drill, record, review, and submit report. Consequences of non-compliance. So failing to comply with safety drill requirements and regulations have serious consequences. First is the port state control violations. Ship may be inspected and deficiencies noted. Can lead to stricter future inspections and reputational issues. Next is fines or detention. Authorities may impose financial penalties. Vessels can be detained until issues are resolved and can also cause delays and operational losses. And lastly, increase safety risk. Crew may be unprepared for emergencies, higher chance of accidents, injuries, or damage to equipment. It also demonstrates that compliance is essential for safety. So remember, the consequences of non-compliance are port state control violations, fines or detention, and increased safety risks. Last is the engine failure drill procedure. An failure drill prepares the crew to respond quickly and safely when the main engine stops working. It tests both the crew's readiness and the ship's system to ensure smooth recovery and prevent accidents. So this section explains the step-by-step procedure for conducting an engine failure drill. So the purpose is to train crew to act quickly, safely, and correctly. Step 1 is recognize the failure. Observe alarms and indicators in the engine room. So we can identify like the types of failure. For example, loss of power, low oil pressure, high temperature, or fuel system problem. For example, the alarm sounds in the control room and the main engine shows a sudden drop in oil pressure. Crew notices smoke near the fuel injector. So step 2 is to report the failure. Immediately inform the chief engineer. So give clear details like location, type of problem, and current status. For example, crew member calls for chief engineer via intercom. Main engine stopped. Low oil pressure detected near cylinder 3. Investigating fuel system. Step 3. Take corrective action. Follow emergency procedures according to the engine room manual. Only trained personnel operate machinery during drills. So for example, the crew shuts down the engine, check oil levels, inspects fuel lines, and ensures cooling water is circulating. Again, only certified engineer handled the machinery. Step 4 is to restart engine safely. So verify all systems are normal and safe before restarting. Ensure the engine according to standard procedure and confirm engine parameters. For example, after verifying oil pressure and temperature are normal, the engineer starts the engine. So it shows normal reading and the engine room runs smoothly. And step 5, secure the end record. Secure the engine and any equipment used and write drill details in the logbook for documentation. So for this is assess crew performance or secure engine and equipment use and also for future references. For example, after verifying oil pressure and temperature are normal. After that, in the engine room logs, put the date, drill, action, and the result. Step 6 is review drill results. Review crew performance and action. Identify areas to improve for next drill. So for example, during the debrief, the chief engineer notes that the crew responded quickly, but communication over the radio could be clearer. Timing was good, no mistakes. That is sample for step 6. And lastly, continuous improvement. Lessons from each drill help improvement. The goal is to prevent accidents and ensure safe operations at sea. So last is the summary and conclusion. So let's make a recap for this lesson. So let's review the key points for today's session on engine failure drills. So engine failure drills simulate real engine problems in a controlled environment. They prepare the crew to respond quickly and correctly, ensuring that actions taken during actual emergencies are accurate and safe. Prepared the crew to react quickly and correctly. When the crew is prepared, the risk of errors or mishaps is greatly reduced. Engine room safety precautions and critical purpose drills. So engine room safety precautions. Always wear personal protective equipment like helmets, gloves, safety shoes, and ear protection. Avoid hot surfaces, moving machineries, and electrical hazards. Keeping the engine room clean and organized also minimize risk. Critical purpose of drills. So drills helps identify weakness before real incidents occur. They improve reaction time, enhance teamwork and communication, and they build confidence and discipline among all crew members. Regulatory requirements and compliance. So following international regulations such as SOLAS and the ISM code is mandatory. Drills must be conducted regularly, recorded in the logbook, and reviewed. Compliance ensures safety, prevents fines, and meets international standards. Engine failure drill procedures. Step 1 is recognize the failure, detects alarms, abnormal readings, or visual signs. Step 2, report the failure. So communicate clearly with location, problem type, and status. Step 3, take active corrective action. Follow emergency procedures to prevent damage. Fourth is restart engine safely. Ensure all systems are normal before restarting. And step 5, secure and record. Log actions, results, and observation. Step 6, review drill results. Debrief, identify weakness, and refine procedures. And step 7, continuous improvement. Regular drills are essential because they build three key qualities in the crew. Readiness, know exactly what to do when an emergency occurs. They act quickly and confidently, reducing the chance of mistakes. Coordination. Drills ensure that everyone works together smoothly. Each person knows their role and actions are synchronized, which prevents confusion and delays. And safety discipline. Repeated practice instills a culture of safety. Crew members develop habits of following procedures, using proper protective equipment, and prioritizing safe operations at all times. So, in conclusion, safety first, engine failure drill saves lives and prevent accident, preparedness matters. Trained crews react calmly and effectively. Clear communication. Simple English ensures accurate reporting and coordination. Regulatory compliance. Following rules protects the ship, crew, and company. Continuous improvement. Every drill is a chance to learn, review, and improve procedures. So to recap, we'll do a short Q&A to review drills, purpose, causes of engine failure, proper procedure, and key safety and regulation points. I'll give you 5 seconds to answer on your own. So be ready. Question number 1. What is the main purpose of an engine failure drill? A. To test the ship's fuel efficiently. B. To practice handling real engine emergencies safely. C. To inspect personal protective equipment. Or D. To perform routine maintenance on the engine. If you answered B, that's correct. Well done. Question number 2. Which of the following is not a common cause of engine failure? A. Fuel system problems. B. Lubrication failure. C. Excessive crew communication. Or D. Electrical faults. If you answered C, excessive crew communication, that's correct. Great job. Question number 3. During an engine failure, what should the crew do first? A. Restart the engine. B. Identify the alarm and type of failure. C. Secure the engine room. Or D. Record the incident in the logbook. If you answered B, identify the alarm and type of failure, and that's correct. Excellent. Question number 4. Which safety equipment is essential for working in the engine room? A. Hard hat, safety shoes, gloves, ear protection, and coveralls. B. Life jacket, whistle, binoculars, and helmet. C. Safety goggles, helmet, life raft, and gloves. Or D. Safety shoes, oxygen mask, helmet, and flashlight. If you answered letter A, and that's correct. Nice work. Question number 5. What is the key reason for using short and simple English during drills? A. To avoid misunderstandings and ensure clear communication. B. To practice for speaking exams. C. To save time during paperwork. Or D. To confuse new crew members. If you answered A, that's correct. Well done. Question number 6. Which international regulations require ships to conduct regular safety drills? A. Marpol and Col Reg. B. SOLAS and ISM Code. C, STCW and IMO guidelines. Or letter D, ISO 9001 and ISO 14001. If you answered B, that's correct. Good job. And lastly, question number 7. Which of the following is a benefit of conducting regular engine failure drill? A. Reduces the need for protective equipment. B. Builds readiness, coordination, and safety discipline. Letter C. Replaces the need for maintenance checks. Or letter D. Increases travel speed of the ship. If you answered B, and that's correct, good job. Practice, prepare, protect. A safe crew keeps the ship safe at sea. Today, we'll learn that the engine failure drills are more than just exercises. They are essential for safety at sea. By recognizing failures, reporting promptly, and taking corrective actions and reviewing our performance, we build confidence, teamwork, and preparedness. Following safety procedures and regulations like SOLAS and the ISM code ensures not only compliance, but also a well-being of everyone on board. So remember, being ready is the key to preventing accidents and handling emergencies efficiently. So let's continue to practice, prepare, and protect. Thank you for your attention today. In our next lesson on Wednesday, we'll be focused on steering gear failure, learning how to respond quickly and safely to ensure that the ship stays on course, stay prepared, stay safe, and see you again